I needed something to hold my dry erase markers, and I've been getting a lot of questions lately about 3D printing, so I thought this would be a good opportunity to walk you through the entire process of modeling, slicing, and printing in 3D.
Respect all of the wild. This are the life sign. Cosmic galactic shine.
Now, something like this is pretty easy to go buy at the store because it's really just a piece of plastic. But part of the fun of 3D printing is not buying cheap plastic at the store. You can design and model things to suit your specific needs, plus you get to go through the actual process of making something. It would also be pretty easy to find something like this on one of the sites like Thingiverse or My Mini Factory, where you can download 3D models for printing, but it's also really fun when possible to design your own prints, especially if they're practical. And even though this is a very simple shape, the reason that I wanted to design it myself is because I wanted to make sure it held the exact number of markers that I needed and that it would fit in the exact spot that I'm going to mount it. So where do you begin? How do you take an idea like this from your head and bring it into the physical world? To do the actual measuring, I just used some digital calipers I got at Harbor Freight for pretty cheap. And basically these just open up so you can measure different elements and see exactly how big they are in millimeters. Once I measured the markers and the door, then it's time to actually design the holder in a 3D modeling program. So if you don't know where to begin, I recommend Tinkercad.com, which is an online-based CAD program, 3D modeling program, which is great because it's very easy to use if you're brand new, but if you have a little more experience, it does have some pretty advanced features as well. Another benefit to Tinkercad is that it's online-based, so you can log in from any computer and continue working on your designs, and it's really easy to share them as well. Now, just some of the very basics. There's a work plane here you can rotate to see the different dimensions, top, front, right, and left sides. And pretty much any design you make in Tinkercad is going to evolve from the use of some combination of shapes. Solid colored shapes are solid objects. These ones that have lines in them are holes. They're essentially negative space. So for what we need to create today, I'm going to start with just a box. The color of the box doesn't matter because the color of the final object will be determined by whatever filament we end up using. This just needs to be the size I measured based on the markers. So this is the actual size of the marker holder. And that's pretty simple. I just need one side to be 20 millimeters, which it is already. I would like the other side to be 105 millimeters. And then for height, I would like it to be 88 millimeters tall. It's a big rectangle. And this is the size of the space where the markers need to go. The problem is that this is a solid object. So if I print this, it's just going to be a solid rectangular object and it's not going to do anything. So what I'm going to do is click on this object and then duplicate it. So now I have two of them. This second one I'm going to make slightly larger. So instead of 20 millimeters wide, I'm going to make it 25 millimeters wide. And instead of 105 millimeters long, I would like to make it 110 millimeters long. So now it's bigger in every dimension except height. Instead of 88, I'm actually going to make it a little smaller and I'm going to make it 85 millimeters. And I will explain why in a second. So now I have these two shapes, which are very similar, but one's a little bit bigger than the other. I'm going to take the first shape, the smaller one, and I'm going to change that from a solid to a hole. So now that's negative space. And if I move that over the second object, you can see it actually cuts out space in that object. That's why the second object was a little bit bigger, because it's essentially creating the shell that's going to hold this negative space. Because this is the size of what needs to hold the markers, but this is the size of the shell that actually needs to be the physical object. The reason I didn't make the second shape taller was because I wanted it to actually be a little shorter than the negative space, so that way it will cut off the top and allows you a spot to put in the markers. Now in Tinkercad, when you're moving objects around, you can just drag them with the mouse, you can move them with the arrows, you can change the way the grid works, you can snap to grid, you can turn that off. If I were to try to line these up by hand, it would probably be kind of a maddening experience, and I don't feel like going totally insane today. So I'm going to select both of these, and I'm going to click this Align tool. And it's going to give me the option to align via the center dimensions. And so now it doesn't matter what angle I'm looking at, both of these shapes are aligned perfectly based on the center. So right now, since both of these are resting on the same plane, the negative space is interacting with the solid object, and that means this is just going to be a tube. It's not going to have a bottom to actually hold the markers. So I'm going to take the negative space and just drag it up a little bit. So I ended up raising it just by about 3 millimeters. And now if you look, you can see inside there's going to be a bottom to this container that kind of matches the side. It's not real scientific, I just want it to be thick enough to be strong. And the way I got this double transparent view was just to turn the outer layer also into a hole. So I'm going to switch that back to a solid. Now the solid is filled with a hole. If I select both of these and click group, it will combine them into one object. And now this is what our print is pretty much going to look like. It's a very simple shape, but it's pretty cool. Now that we have our 3D model, we need to put it into a slicer before we can print it. So I'm going to export it from Tinkercad, and I'm going to export it as a .stl file. And then I'm going to open that up in my slicer. Since I'll be printing this on my Prusa i3 MK2, I'm using the Prusa edition of Slicer, but the settings would be the same no matter what slicer program you're using, whether it's Cura or Simplify 3D or something else. This is a simple model. It doesn't need any kind of supports as long as it's printed vertically like this. For print settings, I'm going to keep layer height at 0.15 because that works best on the Prusa. I'm going to keep first layer height at 0.2. There's not going to be a lot of infill, but I'm going to keep it at 20% because I think that will make it quite strong. And we don't need any rafts, we don't need any skirts or anything like that. For temperatures, we'll keep the main print at 205 degrees for the extruder and 55 degrees for the bed. That should be good. The first layers are a little bit warmer at 215 and 55. And that's pretty much it. So if I click on slice, it will now take the 3D model and slice it. So now if I preview it, you'll be able to see how the printer is actually going to print this. So it starts with that bottom layer and just goes all the way up. Shouldn't need any supports, everything should be fine, and I will export the G-code. We'll just save this as marker holder to the desktop. I'll also put a link to this file in the description so that way you can download it and print it or mess with it if you want. I'll put the G-code and the .stl file. And that's it. Now the next step is to put it on the printer's SD card and load it into the printer.
Yeah, man.
So that's it. That's pretty much the whole process from coming up with the idea, modeling it, slicing it, and printing it. So I hope you found that helpful and interesting. Be sure to check out some of the other videos I posted about 3D printing. I've also included the .stl and the G-code files for this 3D model in the description below. And if you have any questions about 3D printing or 3D printers, feel free to ask and I'll do my best to help answer them, because even though it can sometimes be complicated or confusing, ultimately it should be fun. And so my goal is to help you keep it fun.
See how me have to do it.